Okay, so we're going to try and give this a shot. We're going to try to record the lesson, have you try a couple problems at home, pause, repeat it if you need it, whatever you need to do to get there. But logarithmic differentiation isn't really too bad. That's what we're covering today. Okay, so let's look at this and try to do this example first. Basically what you're going to do is you're going to use some pre-calc skills to take the ln of both sides, and then you're going to use that to simplify the equation. Now sometimes you don't need to use log differentiation, but it just makes it easier, and sometimes you have no choice. In this situation, we don't have to use log differentiation here, but it will make it easier. So this whole function is 0 if x is 2, so we want to just assume x isn't 2, so that this problem is useful and usable. So basically what you're going to do is you're going to take the ln of both sides, just like you can add 2 to both sides, just like you can divide both sides by 2, just like you can square root both sides. You can also, from pre-calc, you remember, take the log of both sides. So I just ln'd both sides. I ln'd that and I ln'd that. Now why did I do it? Because if we use the log properties, and I do encourage you to review log properties if you don't remember them, if we use log properties here, we can get this simplified a lot easier. So I'm not going to do any calculus at this point. I'm just going to rewrite, and I'm going to try to think about what this can be. So I have the log, I have ln of a fraction, so whenever you have ln of a over b, that's going to be ln of a minus ln of b. So let's think about what a would be in this situation. Well, a is x minus 2 all squared. And b in this situation is the square root of x squared plus 1. No calculus has been done yet, but we've used that one log property to make it into two problems that are a little bit easier than trying to just straight up take the derivative of all of that. That would be crazy. Taking the derivative of all of that, like by brute force, would be tough. So assuming you're okay with that rule, there are more properties that can make this much simpler. So let's try another one. Next property I'm going to use is that when I have ln of something to a power, so let's say an a, something to a power, you can bring the power down, and it's not actually calculus. This is a log property. This is pre-calc. This is very similar to the power rule. It looks like the power rule, but it's not the power rule. So you can bring the exponents down in front. You might want to make a quick note that this is actually to the 1/2, right? This is the 1/2 power because it was a square root. So if that's the case, then let's use this green rule to rewrite. So ln of y, we're doing nothing calculus-wise here. Simplifying by straight up log properties. If you don't remember them, you have to go back and review them. You have to. I can give you worksheets, whatever you need, but you've got to review those. Now we have this right here, and now we're going to do calculus on this. We have not done any calculus to this point, but now we're going to use calculus. So we're going to take the derivative for x, or with respect to x, of this. So take the derivative with x of this whole thing. So the derivative of ln of y is going to be 1 over y. The derivative of ln of x is 1 over x. But there's a chain rule here that says dy dx must be used. Okay? Feel free to go back and look at the chain rule or the implicit notes if you're confused about that. Then we're going to go to the other side. Well, the 2 stays. And I like to think about this as like a shortcut. This is x, so we don't have to worry about any implicit. It's really just the derivative of what's in the box over what's in the box. So that's a shortcut. The derivative of that, what's in the box, is 1, and what's in the box is x minus 2. And this is multiplication. So we're on to the next one, 1/2. It's going to be the derivative of what's in the box over what's in the box. So here's what's in the box, and the derivative of what's in the box is 2x. So we've really done it. That's it. But what are we looking for, really? We're looking for dy dx, right? dy dx is what we want. So to get dy dx, we should multiply y on both sides. So we multiply y on both sides, we'll get dy dx. Hey!
Do you mind handing these out to your next?
Okay, so that's really it. We can simplify a little bit real quick, but these y's are canceling out. Oops. These y's are really canceling out at that point, right? And you have dy dx, the derivative, the slope of the tangent line, the change in y over the change in x is equal to, I guess it's 2 over x minus 2. Those can cancel, so it's negative x over x squared plus 1 all times y. Sometimes people will take what y is equal to from the original and plug it back in. They'll take this whole thing right here, which is y, and they'll bring it down and plug it back into where we were, you know what I'm saying? Which would be here. I'm only going to require that. When I require that, I'm going to say in terms of x. But if I don't say in terms of x, which means I need x's all in my answer, then I'm assuming you can leave the y in there. Go ahead and leave the y in there, no big deal. So that's really what we're doing. If you have any questions, please reach out. But what I want you to do is on the notes, try page 180, number 63. This is a problem that has a video for the QR scanner, so if you want to use that, you can go ahead and use that. But try this, and you have the space there to do the problem. So feel free to pause the video, try that, and then we'll pick it back up. Okay, so hopefully you did that and it went well. Because it's an even, you can check the answer in the back of the book. They might have plugged back in for y. Let me take a quick look, actually, in the back of the book what they did. So when I go there, sorry to waste time here on the video, but it would be important to see that, I think. So when we go there, chapter 2, section 5, and it was number 63. I see the answer that they have, the form for the answer they have is 3x cubed plus 15x squared minus 8x over 2x plus 1 all cubed, the square root of 3x minus 2. So it looks like they plugged back in for y, just FYI. So if you plug back in for y, you should be able to get that to match. Yeah, so hopefully that went well. So if that did go well, now we're going to go on to the next problem. So here are kind of your steps, right? ln of both sides. So take the ln of both sides. So we have ln of the first side, and we have ln of the second side, which is this. Oops. It's 1 plus x to the 1 over x. Okay, step 2 is to simplify. And that means use log properties. That's from pre-calc. You have to know those. You have to. So let's simplify and use the log properties. I'm going to bring down the exponent, which is not the power rule. I'm not doing calculus yet. I try to emphasize that a lot. We have not done any calculus to this point. So that's really simplified. It wasn't actually that bad. This example, by the way, is one where you have to use implicit. I mean, where you have to use logarithmic. You actually, whenever you have an x to an x of some sort, you're used to taking a number to a variable. You can take the derivative of that. You can take a variable to a number like x to the 4th. So you can take that derivative and you can take this derivative, right? But the one you can't take is x to the x. So this is just straight up power rule. This is a log of a different base rule. And this has to be logarithmic differentiation. So that's why we're covering this right now. What you want to do then is to take the derivative. So now you're going to derive both sides. So 1 over y dy dx by the chain rule, because we have a non-match. And then this is actually going to be a product rule. So derivative of the first, I'm just running a little bit out of time, so I'm going fast, times the second, as is, plus derivative of the second, which is going to be 1 over 1 plus x. That's the derivative of this, times the first as is. So you've really done it at that point. You just need to multiply by y on both sides and simplify. Not the best, but a little time crunch here. So that's what you want to be able to do. And at this point, you should pause the video and try page 180, number 68. Feel free to rewind if I went too fast, or reach out to me directly. So try that problem, fill it in your notes, and we will see you tomorrow.